Hello everyone. Move forward with this our C programming session 13. We shall see about union, yeah, definitions, declaration, and how to access that union. Basically, what is an union? Union is to store that which is very similar to a structure, but the thing is structure all the members will use different memory location, but union members will use the same memory location. For example, if we are having integer and character, and integer will be a 4 bytes and character will be a 1 byte, then whenever we are accessing that integer, we will get that 4 bytes access, and whenever we have character access, we will have 1 byte access. Basically, union will be allocated with the storage size, which is maximum of member, which is the maximum of the size which is in the member. For example, here we have, if we have the union with the integer a and character b, then integer a is the highest 4 bytes. That will, the total size of the union will be a 4 bytes. And if you do that character a of 10, and then we can see with that we can able to see here, for example, with respect to the difference between the union and the structure, that we can able to see over here, union.c. I'm going to include stdio.h, and then I have integer my integer argc character star argb. Return 0. I'm going to define two things. One is with structure, one is with union. Struct student, maybe I cannot do this way. Struct sta, we can give, I'm going to give integer a and character b. In the similar way, I'm going to use union, una, and then I'm going to give two members similarly, integer a and character b. Basically, in the structure, we will be getting a 4 bytes, and then b is as 1 byte, then padding added with the padding, it may comes to 5 bytes or 8 bytes. Here we have 4 bytes and 1 byte, we should get only 4 bytes, since all the members will use the same memory location for the data. Basically, printf, I'm going to do struct colon %d and union colon %d, and then /n comma size of, I'm going to use size of struct sta and size of union una. Yeah, that should be fine. Now we will see what happens. gcc -o union.c. It says a warning, argument type is integer, but it was long. That should not be an issue. Maybe we can long unsigned integer, maybe we can use for the long unsigned integer, we have to use lu, u for unsigned integer and l for long. Yeah, now we don't have any warning here. Now we are printing. Yes, now we are getting that thing over here, something like this, that integer a is 4 bytes and character b is 1 byte, and then added with the padding the struct size is coming with 8 bytes. Here all the members will be going to use the same location, same memory location for that accessing. Integer a is 4 bytes and this one also 1 byte, and which is maximum is 4 bytes. In order to store that integer, which is the maximum the maximum size of the element present here, then we are getting 4 bytes here. Maybe we can add uh, one more variable, maybe, yeah, character x of 10. Now we should, maybe it should be rounded off with 12, rounded off with the divided by 4. Maybe we can see now what it happens for both dot slash union. Yeah, here we are getting 20, then we have added 12 bytes added to it. We have 8 plus 12, we got 20 for the structure, and we got 12 is the maximum size that it is used over here. Something like this character x of 12 is the maximum size it has to be used in the union, since it has that as it is going to use the same memory location. That's why we are getting the size of 12 over here. For example, in the union, when you are changing any one of the variables, others also will get changed. In case of structure, each will have different memory location, and when you change any variable, it will that will affect to that variable only. But the thing is, here union, it uses the same memory location. All the members uses the same memory location. Then whenever we do something different, for example, that we can give it, it uses that whenever we change any variable, that will be get affected, that the other variable will also get affected, since it uses the same memory location. Maybe we can see how we can use this to convert the multiple bytes. For example, we can have it like bytes to, for example, 32-bit for integer, we have to convert into the 4 bytes. How easily we can do with the union, that we will see over here. Maybe un byte.c. Here I'm going to do include io.h and then integer main character, integer argc comma character star argb. I'm going to do a thing, union una, maybe here, and I'm going to do integer a, and then maybe we can use unsigned, unsigned integer a, and then unsigned the character x of 4. Yes, now I'm going to do this in the hexadecimal format. Maybe printf enter the integer colon 0x scanf. I'm going to do percentage x to scan it like x hexadecimal format, and I'm going to give una. We have to define a variable struct, sorry, union una equal to u. The here union is the keyword and una is a union name and u is the union variable name that we have to use to access. U, the access can be done with the dot. After that we have to do a for that accessing that a for the member, and for the scanf we have to use ampersand over here, and we can print that printf integer colon percentage x slash n comma u dot a. Similar way, character of 3 colon percentage x, and then character of 2 colon percentage x, and then character of 1 colon percentage x, and then character of 0 colon percentage x I can give, and we can do that u dot x of 3 comma u dot x of 2 comma u dot x of 1 comma u dot x of 0 over there, that we can able to see. GCC -o unbyte dot c. I can give unbyte to run. I'm going to enter 1 1 2 2 3 3 4 4. Yeah, now we can get that we got that byte by byte splitted here. For example, we have given in the integer 1 1 2 2 3 3 4 4, that got splitted. Character of 3 is 1 1 and character of 2 is 2 2, and character of character of 3, that is maximum most significant byte, is 1 1, and next significant byte is 2 2, and the next significant byte is 3 3, and we have next significant byte 4 4, which splits that integer into 4 bytes separately. That can be done with the union. That's also a feature for the union to use. This will be used in the location something like networking stacks, that can be used to split up and get the data from that packets. Basically, that can be used over in the stacks and everywhere. That depends upon the usage. Basically, this is one of the applications that you can use the union basically. And here we have further, we can access with that union, with the union, and then I just recopied, that's why it came here, union, and then union name and union variable name, and access can be done using the union variable. Dot is the operator to access that, and union variable name, in our case u dot a, that we used. The u is the union variable name and a is the member basically, that we have used. And we have, similar to structure pointer, we also have union pointer over here that can be accessed by using a arrow operator. Basically, that union pointer points to the address location of union, that it points to that location basically, and it can be the members can be accessed by using that arrow operator, and the arrow should be placed, that access operator should be placed in between that variable pointer name and then member. For example, here we have union and then union name, and then union star is the for pointer for integer, star ptr is the integer pointer. Similar way, union una star ptr is the union a structure union pointer. It's something like similar, that once we define the pointer name, we can access the member using the union pointer name with using that access operator basically. here we can have it something we can put unptr.c unptr.c, and I can do include stdio.h, and then integer main integer argc comma character star argv, so that we should get as it is. If anything we have to do, I have to define union una integer a and then character b. Maybe we can use this, for example, union una star ptr maybe, and then maybe you can define union una then u, and I can reuse that scanf things, control wf, and then e unbyte dots, sorry, I open e unbyte dot c. Can use this, no need to type it again. Why? Paste over here. I just received with the ua. For example, here I can use we can use ptr assigned with the pointer of union, that can be assigned, so that we can use here ptra ptra, then we will be having ptrx, and then ptrx, and then ptrx over here, ptrx, then we will get that value. Basically, instead of directly accessing the member, we are directly initializing the pointer to that one, and then we are accessing here gcc -o unptr.c. It has huge thing that it has given something like this. We missed to given character x of 4, that's why we are getting this many errors. Yeah, it got solved on ptr. Yeah, I'm going to enter now 1 2 3 4 5 6 7 8, and we got the results similarly. The ms byte is 1 2, and then the next significant byte is 34, and then next significant byte is 56, and next one is 78. Yeah, this with the playing with the structured union pointer that can be accessed with the operator. Thank you for watching, and if you are in if you can contact me at nvhariharan@nvtech.com for any clarification or any training assistance. Thank you for watching. Subscribe for more updates. Thank you. Have a nice day. Bye.